Okay, assuming that this is recording correctly and you can hear my voice, let's get started. Today's lesson is going to be 2.6. If you are joining us online, please remember that I have made an announcement on Brightspace regarding our Chapter 2 assignment. So take a look at our Brightspace and make sure that you are not left unawares. Chapter 2.6, Solving Inequalities Algebraically. We are looking at this as a continuation of our lesson from yesterday. I hope you'll keep up tabs. Yesterday, we looked at inequalities, what that might mean. Thank you. There are a lot of people coming for it. Appreciate that. Okay. Yesterday we looked at inequalities, what that means, how it compares with a number or a function or a whole bunch of different things. I hope you got a chance to graph or use some technology to get used to what it means to be above or below a certain line. Now, everything we did yesterday and up to chapter 2 was regarding a graph. And that's sort of like the introductory skill. Today, we're going to look at how the graph compares to when we're just using numbers, aka algebraically. And I want to introduce something that I call the chart method to do exactly what the graph does, but I want to move on to not graphing it at all and still getting the same information because it's a great first taste of what calculus is. This method that we do, you'll probably see it more than once as we get through the middle of functions and we move on to calculus skills. All right? There's another method called testing cases. It's very useful for absolute value functions, but the textbook doesn't do a very good job of explaining test cases, and we won't really run into absolute value functions anytime soon. So I want to just focus on the chart method. Okay? My first period class was very tired today and didn't want to really think, so I just demonstrated example 1. Would you like me to? Example 1 is supposed to be a good summary of everything we've done so far. Would you like me to demonstrate example 1 and you try afterwards? A lot of people are nodding. Probably don't want to think much because you're tired. Let's get started. I have a question that says, solve when something is less than or equal to 0. Quick recap, I ask you to do this for me. What does solve mean in this context? And please don't just say, find x. There's more to it. Christian? Make the equation true. Make this, in this case, inequality. That's right. Solve for x. Let me write this down. Solve for x that makes this sentence true. And I'm going to go a little bit deeper. Solve when this inequality is true is the same as saying, solve for x that makes the function a negative or 0. That's what this question is trying to say. Does that make sense to people? Solve when the left side is less than or equal to 0 is like saying, can you tell me what x value makes this function a negative or 0? When is this left side going to be a negative value? That's what we're looking for. And now, wouldn't it be nice if we had a graph? Like if I had a graph, right? Graph, and it's a cubic, but it's upside down. It's new today. Okay, so think about this. It's cubic, it's negative, so it's going to be something like this. When is this graph less than or equal to 0 is the same as saying, when is that a negative? And when is that a negative? That's what they're asking for. Let's do it algebraically. First things first. If you want to start graphing something, you need to identify what these x-intercepts are. So let's do it. How do we go about factoring this? The factors which make b over a true are factors of 16 divided by factors of -2. So how about I break this down? Factors, B is going to be plus minus 1, 2, 4, 8, and 16. Question?
Factor of 2.
You could.
Won't that make it easier because then you just do the factors?
That's a good point. Let's do it. Okay. One of your fearless class members thought, why not make life easier by factor? I like that. I appreciate that. I didn't even see it myself because I'm not thinking right now. I'm on autopilot. Okay. All right. Now, since the a value for this polynomial is now, since the leading coefficient of this polynomial is now 1, all I have to look for are the factors of b over a, which is just 8, right? So factors of -8 are plus minus 1, 2, 4, and 8. So let's test it. Let's see, I'll do it for you. Again, just trying to save you brain space. F of 1 is 1 plus 3 minus 6 minus 8, not a 0. F of -1 is -1 plus 3 plus a 6 minus 8. Oh, okay. That's a positive 9. That's a -9. It's going to be a 0. Therefore, x plus 1 is a factor. Okay. So let's continue. If that is true, I can synthetic or long division, because we're trying to divide this, right? What would you prefer? Synthetic? Okay. That was unanimous. Here we go. All right, so let's make this into factors so we can better analyze it. 1, 3, -6, -8. And I put the root, which is -1. 1, multiply, add, multiply, add, multiply. And yes, we got it right all along. There's a confirmation. The remainder is 0. So I know I did this correctly. Like these two should agree. Agree. Okay, so taking this, since I have some space here, I am going to move this up. That means my function is now -2. My factor of x plus 1, and my trinomial is, my cubic function is now x squared plus 2x minus 8. That is less than or equal to a 0. So there's one x-intercept, right? Next. Yeah, you could do the factor theorem again, but you have so much practice with quadratic functions that I think you can do it in your head. Two numbers that multiply to -8 that adds to 2 is a positive 4 and a negative 0. Oh, -2, my bad. Which means the zeros are all from here. -1, -4, and 2. So I clearly overshot. -4, -1, and 2. So my graph is more like that, isn't it? Right? -4, -1, and 2. So Graphing it, I can figure it out. I have my zeros. I have my leading coefficient of this function, which is -2, right? And because I know it's cubic, I can match it up. But what if the question was so complex that graphing it was going to be annoying? Or you really do want to know how we can calculate all of this with numbers. This is where I believe the chart method is the most advanced. Take a look at this method, and my answers for this quote-unquote chart method is going to match with your minuses and your pluses here. So let me fill this in a little bit. So that's my curve. Up here is going to be plus, and up there is going to be plus, right? Chart method. So I'm not sure if the textbook calls it interval method, but it's pretty much the same thing. Please create a t-table, but the right side is much longer. And here's how we fill the chart. On the top right, you want to put in all x-intercepts and vertical asymptotes. Now, the vertical asymptotes we haven't learned yet in grade 12, but it's going to come. For the sake of having a complete lesson, I want you to add and VA to your notes. But for the moment, we're not going to talk about it. All we have in this question are x-intercepts. Okay? So this is my heading. Please put all x-intercepts in order. So -4 is first, leave some space. Then -1 is next, leave some space. And 2 is last. On the left side, I want you to add all factors. Maybe if I zoom in, it's easier to read. All factors that could change signs. In other words, pluses and minuses. What does that mean? Well, based on our equation so far, we have a -2 could change the sign of the function. X plus 4 could change the sign of the function. X plus 1 could change the sign of the function. X minus 2 could change the sign of the function. And at the very bottom is my function sign. Okay. We are going to plug in random x values for each of these to figure out if it's going to be a plus or a minus, which will tell me what the overall function sign is going to be. All right, -2. No matter what the x value is, a -2 is always going to be a -2. So just put minus, 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 minus. Okay. I don't know, Ethan, choose a number below -4. Below -4. Sure, any number. It could be, you could have done -1 million, doesn't matter. -6 plus 4 is a negative value. A -6 plus 1 is a negative value. And a -6 minus 2 is a negative value. So if I have x equals -6, that would be -2 times a negative number times a negative number times a negative number. What's the overall sign? That's right. It is going to be positive. Let me write -2 times a negative times a negative times a negative. Oh, a positive? that sort of matches with my graph. Okay, let's go. A number between -4 and -1. The easiest number that you won't have trouble with. A number between -4 and -1. That's easy for you. Huh? Not including. Because we already know if it's -4, the function will equal a 0. If it's -1, the function will equal a 0 and a 0. Yep, sure. -2 is always -2 here, right? This line is always -1. -2 plus 4? Positive. -2 plus 1? Negative. And -2 minus 2 is a negative. So what is -2 times a positive times a negative times a negative? The function will be negative. Does that agree with my little sketch? Oh, a number between -4 and -1 will be negative. So what do you expect? If I choose, let's say, a 0, x equals 0, positive or negative? It should be positive. Let's go. A number between -1 and 2, yeah, I think the easiest number is a 0. -2 is always negative. 0 plus 4? 0 plus 1? 0 minus 2. So, -2 times positive times negative. Positive. So yeah, it matches. And then any number bigger than 2, I could choose 1 million. A million plus 4, a drop in the bucket, right? It's 1,000,004. A million plus 1, still 1,000,001. A million minus 2, that's a tiny subtraction compared to a million. It's a positive. So negative times 3 positives, minus. So, what parts are we interested in? Go back to the question. The question wants the function less than or equal to 0. So I am interested in the negatives, including the 0. I am interested in the negatives, including the zeros. So for set notation, -4 to x to -1, or 2 to x to infinity, which I'm not going to write. If I were to write this as set notation, you would say from -4 to -1, include both. Union. From a 2 to a positive infinity, include the 2, but you don't include infinity. Set notation, interval notation. So in my opinion, I think the chart method is most efficient. Some textbooks, like ours, provide more than one solution. It shows the case method, it shows the interval, whatever. It asks you to try this, try that. I think this is the most foolproof. You just follow the steps. It will always give you things that match. What's also nice about chart method is if you make a mistake, it shows up and you're like, that doesn't make any sense. And then once you are confident in your chart method, when you see funky things happening, you trust your math so much that you're like, this must be true. So what in the world does a graph look like? And you apply this onto a graph you've never seen before. So it's supposed to help both ways. Yes? Fair question. The question was, why are all the signs for the -2 row all negative? It is because no matter what the x value is, the -2 is a constant. It's not an x value. So no matter what that is, it will always stick as a negative. And the reason I put the negative there is because it will change. It will affect the overall sign.
And you put that there because that was the number we were factoring in.
Yes. So if we didn't, then it would be included there. So if the a value was like +50, do I need to add another positive there? No. that positive doesn't change the sign, but a negative does. Yes?
So these are like what we're plugging into X.
Any number underneath or beneath my 0. So anything left of -4 on the x-axis. Imagine this part to be the x-axis.
Yeah.
So like here, any number to the left of -4, I plug in.
Yeah.
And that'll give you a positive.
And then negative in between.
Yes. Choose any number between here, and when you plug it in, it'll give you a negative, positive, negative. That's right. Yes.
Where are you question like this on a test? Will we be given the appropriate time to do this whole test?
I hope so.
Looks like it takes a really long time.
You know what? I think the chart method being new, it will take a while, but I've never had, all of my students in my past have always rose to the occasion through their practice. This doesn't take that long if you know what you're doing, and so we'll get there slowly. Just got to keep on practicing. In fact, I'm going to ask you to try it right now. I only have one more example with you. Oh, question? Yeah. I only have one more example with you. That's literally the end of my question. So you can say, so therefore, f of x is smaller than or equal to 0 when x belongs to blah, blah, blah. Okay? Yeah. My only thing today is one more example. I'm going to ask you to try to model everything you learned so far up to the zeros. The chart method, let's do together, unless you want to try it. But up to here is something I do expect you to know how to do for this question. Let me just give a little tip. When we approach this, do you recognize this? I have left side is less than or equal to right side. What that means is one of these curves is lower, more negative than the other curve. Where is that true? Here. You can look at it graphically, but there might not be clear indication of what those values are. So we're going to solve it algebraically. Do you have a tool to solve for x when this is smaller than that? No. But we do have tools when one side is equal to a 0. And we learned that a couple of days ago. I gave you an example. So manipulate this inequality so that you can use your tools that you've learned in chapter 2. Try to get there and try to find the x-intercepts, okay? Go for it. Yes? Yes, you may. Is there a question? Yes. Sure. I will, yeah. I'll give about 5 minutes. Yeah. Not only will it be useful at it's also a good case of practice. When we get into more advanced functions, for example, not just polynomials, but have a whole bunch of asymptotes inside of those, it's really good to know that because this includes what the graph is. So right now, we're going from A to B. Trying to Oh yeah, this class hasn't learned how to do algebra with inequalities. Like, right, you know when signs change. very simple concept that if you haven't covered it, and I know exactly what number is covered. Don't worry about it. And you don't have to worry, it's just plus minus. There's no multiplication in math, right? Just, you have to subtract 5 and subtract 5. So there's no multiplication. Just do that for fun. Almost nine.
I don't get why then. I don't get
How or why?
I don't know, I'm just in the process of.
Long story short, these are how to introduce it to you right now. It's very necessary. Might as well learn to do it. Second reason that this aspect is why we're using your skills to calculate a schedule. You also solve it using straight up numbers. I'm just showing you are that. But not this. That might not be anything to. However, let's talk about what we're doing. On the top, know that at these axes, so we know that how does we know that this is true? Because it is equal to 0, we know that those are the roots. And so we're going to assume what happens? According to the graph, it's going to be negative 1. Okay, well, x is a negative 2. Plus negative 2. This negative 2 stays a negative. This bracket will become a positive. This bracket will become negative. If I plug in a negative 2, negative times a negative times a positive times a negative. Higher function. Yes. So this chart right here corresponds to down, up, ups. Here's up, here's a down, here's a up, here's a down. Up, here's a down, up, here's a down. It's always going to be multiplied by 2. This bracket, if I plug in a negative 3, let's say, a negative 3 plus 4. Yeah, so let's pretend we chose negative 100. We chose a negative value. You know, negative 100 cancels 1. That's negative. As long as it's bigger than 2 and bigger 2, as long as it's lower than 3. So you have these numbers are the so this is the height, not so bad. All right, let's do this. You've waited long enough. There's one fraction, but there are 2 that are normal. Let's do it. Let's do it. Here we go. Let's see. Let me zoom in a little bit. Okay, the first step would be that, because, huh? What do you mean, why can you do that? Of course. Here's my argument. Okay, this might go a little longer than I expected, but here's my argument. Is 2 smaller than 3? If I subtract 1 from both sides. Is 1 smaller than 2? If I add 10 to both sides. Is 11 smaller than 12? I didn't mean to belittle you, but I'm more surprised that, you know, that maybe there was resistance for that. You absolutely can use algebra to bring it. You can also do multiplication and division, but something funky happens if you do that with negatives. So I'm not going to touch that. We'll have a lesson on that hopefully very soon. Okay, but for now, you can absolutely use algebra and make that true, which means, what are the factors of 12? Plus minus 1, 2, 3, 4, 6, and 12. What are the factors of 3, 1, and 3? So, put together, the factors b over a will be plus minus 1, 2, 3, 4, 6, and 12, as well as 1 over 3, 2 over 3, 3 over 3, 4 over 3, 6 over 3, and 12 over 3. Not all of it, of course, because 3 over 3 is 1. We've done that. 6 over 3 is 2, and 12 over 3 is 4. So we have 3 new fractions. Crossing my fingers, let's really hope I don't have to get into the fractions. I'll save you the pains by doing it myself. Okay? F of 1, that's 3 minus 5 minus 6 plus 12. That is not a 0. F of negative 1, negative 3 minus a 5 plus 16 plus 12. That's way too big. F of 2, 2, 4, 8, 24, 2, 4 minus 22, 32 plus 12. Nope. F of negative 2, 2, 4, 8, negative 24, 2, 4, negative 20, 2, positive 32, plus 12. Oh, that works. Minus 44, plus 44. Okay, that's negative 44, that's a plus 44. That means x minus plus 2 is a factor. Let's do it. From here, if you're still with me or you have enough brain power, I am going to do my synthetic. 3, negative 5, negative 16, and 12. My root is a negative 2. Add, multiply, add, multiply, add, multiply, and add. Yay, confirmed. That means, so therefore, x plus 2 and 3x squared minus 11x plus a 6 must be less than or equal to 0. And if you have been following my previous example, we got to keep going because we want those x-intercepts. Let's see. Multiply to 18, add to negative 11, 9, 2, negative 9, negative 2. And so I break that down. That would be, I need a negative 9, I need a negative 2. There it is. So what are my zeros? -2, 2 over 3, and 3. I didn't give myself much space, did I? Chart method. One, 2. Write out all my x-intercepts and vertical asymptotes in order. So that's a -2, 2 over 3, and then a 3, and then it moves on forever. Write down anything here that would change the sign. X plus 2, 3x minus 2, and x minus 3. Let me zoom in now. Okay, a big negative number. I'm going to choose -100. Negative plus 2, that's a negative. -100, -300 minus 2, and negative minus. So the overall sign is negative. Dot, 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 dot. At the -2 would be 0. Any number between -2 and 2/3, the easiest number would be 0. 0 plus 2, plus 0 minus 2, minus 0 minus 3. So that would be plus dot, 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 0. And then a number between 2/3 and 3, the easiest one I'd say is a 1. 1 plus 2. 3 times 1 minus 2 plus 1 minus 3. And dot, dot, dot. And a giant number bigger than 3, plus, plus, plus. The answer is plus. So when is the function that we rearranged, when is that function less than or equal to a 0? This one and this one. So sorry for being all over the place, but the answer to this would be, so that would be less than 0 when the intervals are including -infinity to a -2, union 2 over 3 all the way to a 3, union, and that's it. So once again, what does that mean? It means from -infinity to a -2, it makes this function less than 0. And then 2/3 to 3, it makes this function less than or equal to 0. But that's not the original question. It also means that left side function is underneath the right side function in those domains. Going back to the picture, I think you can see it. That is -2 all the way to -infinity. All of this red line, at least on my screen, the red line is underneath. And then from here to there, this must be 2 over 3, and that must be an x value of 3. Here, that red line is underneath the blue line. So graphically, sometimes it's very difficult to see. So here's an example where you can't do it graphically anymore. It does pay to have the skills to solve algebraically. And I use this time to introduce the chart method because I think it's a great taste and it lowers your workload in the future because you have to learn this anyways. That's it. What am I doing tomorrow? I will take up any of these questions by request. Okay? And any time that you have left tomorrow is for your assignment. So we do homework check, any questions that you might have from here, and then the rest of class is for your assignment. From there, After I collect your assignments, I'm going to give you something for the weekend because we've wrapped up chapter 2. Come Monday, we will spend all day Monday reviewing for chapter 2 and questions from the weekend. Okay, so that's, we spaced it out. Yes. You can do it in any way you wish. Okay? But if I ask you to solve it algebraically, you should be able to come to the conclusion without a graph. And if you don't like the chart method, there are some other funky ways the textbook does offer, but I don't think it's efficient. Yes? Any other questions? All right, let's stop the video.